Hi everyone, Emma here from ClusterWare. In my previous demo, I showed you how to uniformly prevent unintended access to your entire cluster of servers using ClusterWare. Now we're cranking up the energy to tackle the second security concern of our cluster, which is encryption of the data in transit. Today's mission: encrypt all application traffic with SSL using the ClusterWare magic. In this presentation, I'm going to reuse the infrastructure setup that I provisioned with ClusterWare in the previous demo. If you missed this 10-minute video, I'll leave the link in the description of this video. Okay, first, let's have a quick reminder of our infrastructure setup. The top server is acting as my application load balancer, distributing the traffic coming from the internet. The bottom two are my application servers, running a Node.js application. Each of the application servers has 2 CPUs, so in total we have 4 application instances behind the load balancer, each running on a different port number. As you can see, all of the traffic in the current setup flows via unencrypted HTTP. It means that if someone captures your application requests or responses while they are transferring through the internet, then your customer's confidential information may be leaked to unauthorized people. Not fun. We're about to lock it down end to end with SSL and, of course, ClusterWare. Okay, so let's get into it. First stop, the load balancing service. Here, when I'm hovering on the config status before the load balancer, I can see that the customer-facing gateway is not secured. Similarly, when I'm hovering on the config status after the load balancer, I can see that the traffic flowing to the application endpoints is not secured either. Time to fix that. We kick off by securing the load balancer gateway. In the load balancing service, I'm navigating to the Gateway Security tab, where I'm going to upload my SSL certificate. First, I'm going to paste my certificate file, then the certificate private key, and the CA certificate. Finally, I can click Upload Gateway Certificates, and all my certificates are on their way to the load balancer. Okay, great. I have my certificates uploaded, and now I can enable the SSL for Gateway option to make the load balancer start using the certificate. Now, back to the Load Balancer Status tab. Reload the Load Balancer config to apply the changes. And as you can see, the Load Balancer port number has already switched to the mighty 443. Okay, fantastic. Now it's time for a quick check. Hit the Load Balancer URL to see it live. If the connection is timing out, try temporarily disabling your firewall on the Server Security tab. Now all customer traffic is fully encrypted with my SSL certificate. Okay, so now let's dive into endpoint security to encrypt the traffic between the load balancer and application endpoints. And I promise this will be even easier. By default, ClusterWare provides one free SSL certificate per cluster. It's like Christmas for your apps. This certificate is passed as an environment variable to each application instance at startup. Let me show you how I get it in the Distributed Timer app. Over here, just before I start the HTTP server, I'm getting the endpoint certificate and certificate key from the environment variables provided by ClusterWare. Next, if the above two are present, and if the Enable SSL flag is present too, I'm starting a secure server with this certificate and key. Otherwise, I'm creating a non-secure server. So all I need to do now is set that environment variable with the Enable SSL flag, restart my application instances to pick that flag up, and make the load balancer require all its endpoints to be secured with that certificate. Let's start with setting the Enable SSL flag. We need to navigate to the cluster dashboard. Then edit cluster and add a new environment variable. The environment variables set here are propagated to all application instances in the cluster at startup, including the endpoint certificate, its fingerprint, and certificate key auto-generated by ClusterWare. Now, I'm saving the cluster settings and navigating to the application service. Here, I'm restarting both apps to make them pick up my new Enable SSL flag. Okay, great. Now let's go to the load balancing service. Back to the Endpoint Security tab. And all I have to do here is click Upload Endpoint Certificate to this load balancer and enable the SSL for Endpoints option. By doing this, I'm telling the load balancer to trust only the applications that have this certificate. Any request without that certificate will be dropped. Once the certificate is uploaded, you'll see green check icons confirming that they are present on the load balancer and that the fingerprint matches. Okay, get ready, last step. I'm going back to the status tab and restarting the load balancer to apply my new settings. Hold on, we're almost done. Once the status sync is complete, ClusterWare will confirm that the endpoints are secured with a green lock icon. Are you feeling the suspense too? If so, let's hit the URL again to verify. Fantastic, we have secured our application traffic in just a few minutes. But before I let you go, I have a small bonus. Let's go to the Security Policies service for a second. Here, you'll find that the auto-generated policy has been updated for our load balancer to allow traffic on the secure port. The principle of least privilege is applied by default. Genius. I'm sure you already know how to apply that policy with just one click from my previous video. Thank you so much for watching. I hope you learned something new today. Now you can go ahead and secure your own application with ClusterWare by following the step-by-step guide I left in the description of this video. If you'd like to learn more, check out my other videos and see how to scale, secure, optimize, and eliminate a single point of failure in your application. See you in the next video. Bye.